Today we will be talking about continuity using double-sided limits. For a function f of x to be continuous at x equal to a certain point a, we need to satisfy this equation, which tells us limit as x tends to a minus of the function is equal to limit as x tends to a plus of the function equal to f at this point. Limit as x tends to a minus, it means we approach a using values smaller than a. And a plus means greater than a or larger than a. So for instance, let's say our a was 3. Our a minus would be something around 2.99 and our a plus would be something around 3.01 or 3.0001 or 3.0001. There is no specific value for a plus, but it just means directly after a equal to 3. Let's put that into an example by starting with an example from a graph. Find whether f of x is continuous at x equal to -1, and find whether f of x is continuous at x equal to 0. So at x equal to -1, it means on this x value. Now, as we said, limit as x tends to a minus, it means smaller than a, and our a here, is -1. We need to find limit as x tends to -1 from the left side of f of x, and limit as x tends to -1 from the positive side of f of x. And we need these two to be equal to each other so that we can have our function to be continuous. Now, if we look closely, limit of f of x as x tends to -1, negative, it means from that side, which means our point is approximately here, which is equal to the y value of 3. Now, limit as x tends to -1 plus, which means from the positive side, which is here. And our y value for that is 2. As we can see here, limit as x tends to -1 minus f of x is not equal to limit as x tends to -1 plus of f of x, then our function is not continuous. That's the whole thing to do whenever we are given a graph. Let's do whenever at x equal to 0. So at x equal to 0, we'll also need to find limit as x tends to 0 minus of the function, and limit as x tends to 0 plus of the function, and we'll need them to be equal so that our function is continuous. So at x equal to 0, it means here. Limit as x tends to 0 minus means from the left side, approximately here. So our value here is 0. We're looking at the y value. And now, limit as x tends to 0 plus, which means from here, which is that point, which is also 0. So our limit as x tends to 0 minus of f of x is equal to our limit as x tends to 0 plus of f of x, which is equal to 0. Then our function is continuous at x equal to 0. We did an example whenever we have a graph. Let's do an example whenever we are given a piecewise function, like this one here. In this example, we're given a piecewise function of f of x equal to x plus 2 for x less than 1, and a function 3x minus 1 for x greater than or equal to 1. And we need to check if f of x is continuous at x equal to 1. As we said, we need the limit as x tends to a minus of the function to be equal to limit as x tends to a plus of the function. And our a here is 1. So we need to find limit as x tends to 1 from the left side, and we need to find limit as x tends to 1 from the right side, and we need them to be equal for our function to be continuous. Now, whenever we want 1 minus, it means everything from that side, which means less than 1. And whenever we need a plus, it means greater than 1. Since we're looking now at limit as x tends to 1 minus, and we have our function here, which tells us x less than 1, which is exactly our 1 minus, as we mentioned here. So to find the limit as x tends to 1 minus, we can directly replace 1 into the function. So we'll have 1 plus 2, which is equal to 3. So our limit as x tends to 1 minus of the function is 3. Now, limit as x tends to 1 plus of the function. 1 plus, as we said, means whenever the function is greater than 1. If we look at our piecewise function, our x is greater than 1 in the function 3x minus 1, which means we can replace 1 in the function 3x minus 1. We'll have 3 into 1 minus 1, which will give us 3 minus 1, which is 2. So the limit as x tends to 1 plus of the function will be 2. 3 is not equal to 2, which means our limit as x tends to 1 minus is not equal to limit as x tends to 1 from the positive side. Therefore, our function is not continuous. And that's the solution for this problem. Let's do one more problem. I gave you here a new example where we have a piecewise function f of x, which is 2 minus x for x less than 3 and x for x greater than or equal to 3. So at 3, whenever our function is before 3, which is 3 minus, we'll be using the function 2 minus x. And whenever our function is after or equal to 3, we'll be using the function x only. Now, to solve a, we'll need to find limit as x tends to 3 from the negative side and limit as x tends to 3 from the positive side to find whether our function is continuous or not. First, to find limit as x tends to 3 minus, we'll be looking here, which tells us for 3 minus, we'll be using our function 2 minus x. So we'll have 2 minus x, our x here is 3. So 2 minus 3, which is negative 1. Now, for the limit as x tends to 3 plus means here, and we'll have the function x. So our function is x, and x is 3. Our two values are negative 1 and 3. And they're not equal. So limit as x tends to 3 minus is not equal to limit as x tends to 3 plus, but then function is not continuous. Let's solve now for b. For b, we are asked to find limit as x tends to 4 minus and limit as x tends to 4 plus of the function and see whether they are equal or not. Now, as we can see in the inequality, we have less than 3 and greater than or equal to 3. And obviously 4 is greater than 3. So we'll be using this function throughout the whole thing. So for the 4 minus and for the 4 plus, since it's also exactly after 3. Now, as we said, we directly replace into x. So we'll have limit as x tends to 4 minus of x, which means 4. And limit as x tends to 4 plus of x, which is also 4. And now, as we can see, the limit as x tends to 4 minus, is equal to limit as x tends to 4 plus, which is equal to 4. Therefore, our function f is continuous at the value x equal to 4. In the previous examples, we always saw a perfect condition, where we directly saw limit as x tends to a minus of the function to be equal or not to be equal to the limit of x as x tends to a plus of the function. But we never saw f of a to change. F of a means the number at the y number at this specific x number. So let's take the above example. We want to see whether our function is continuous at x equal to 1. And as we always do, we need to find limit as x tends to 1 minus of the function and limit as x tends to 1 plus of our function. Now, limit as x tends to 1 minus means at 1 from left side. So our y value is 2. And 1 plus means from the right side. So approximately here, which is 2. Limit as x tends to 1 minus is equal to limit as x tends to 1 plus. So we might assume at the beginning that yes, it is continuous. But we cannot forget this point here. This point is f at exactly 1, which is this. And here it is equal to 3, which does not satisfy this equation, which tells us limit as x tends to 1 minus of the function should be equal to limit as x tends to 1 plus of the function, which is equal to f at 1. We have 2, and we have a 2, and we have a 3, where they are not equal. Then here, our function is not continuous at x equal to 1. These types of scenarios, you might see them most whenever you're given a graph and not a piecewise function.